Okay, welcome back. This is the video for 127, section 11.2 and 11.3. 11.2 is on ellipses and 11.3 is on hyperbola. So let's take a look at those. There was a couple of questions asked. I know I got the discussions up a little bit late, but there were some discussions in the afternoon class about a few problems, so we'll take a look at those and get you going on those. So let's start with 11.2. And number 9. So 11.2, number 9. Before we jump into it, let's just kind of review what should have been in the videos. This is the general equation for a hyperbola. Right? It's easy to graph a hyperbola if it's in this format. For example, if I have something like, say, x squared over 9 plus y squared over 16 equals 1. Right? In 11.2, we haven't shifted anything yet, so we're centered at 0. If I were to graph this equation, I know I'm centered at 0, but a is 3 because my a squared is 9. And a, being under x, tells you how far left and right you go in the x direction. So I'm going to have these 2 points here. Okay. And then 16, which is 4 squared, is under y. So that means I'm going to go up and down 4 in my y direction. 2, 3, 4. And 1, 2, 3, 4. And that's, you can count on that pretty much every time, right? It's a quick way to graph your ellipse. Please forgive the fact that I can't draw an ellipse to save my life, and that looks like a smushed egg. But this is how you would do it just about every time. And then the last little bit for this is that the foci happen C units away from the origin along the major axis. And c squared is always the larger of these two minus the smaller. So it's a squared minus b squared, where a is the bigger of the two. So that is to say c squared is 16 minus 9. So then we have c squared is 7, and then c is the square root of 7. So the square root of 7, which is, somewhere between 2 and 3, would be up here somewhere. So focus 1, focus 2, somewhere in here, right? The vertices, typically we just call the points along the major axis, the very tip, top and bottom. The major axis is the longer of the two. Vertices, sometimes you'll call these major vertices, and major vertice 1, major vertice 2. And then the other ones are often called minor vertices. Although I don't think George talked about that, and that's not something that's particularly important, but you might see that. So, having said that, let's take a look at number 9. Number 9 says we have 9x squared plus 4y squared equals 36. So it's not in the form that we want, right? We wanted, say, x squared over a squared plus y squared over b squared equals 1. So whenever you have something besides a 1 over here, we're simply going to divide it by itself to get a 1. So I'm going to divide everything by 36. And then just simplify. 9 divided by 36, you cancel out the 9s, you're left with a 4 in the denominator. The 4 and the 36, you cancel out the 4s, leaves you with a 9 in the denominator. And of course 36 divided by 36 is 1. And this looks like, well, pretty close to the one that I just graphed, right? My x, my minor vertices are going to go out 2 in each direction. My major vertices are going to go out 3 up and down, right? So if I wanted to graph this, I could do that real quick. 2 in the x, 3 in the y, and I have my goofy looking ellipse, right? Now, the other thing that you would be asked for, of course, is that focus. So c squared is, and again, it's always the largest minus the smaller. So 9 minus 4 is 5. C squared is equal to 5, and therefore c is the square root. You go plus or minus root 5. You're going to go plus or minus root 5 from the origin. Again, along the major axis, that's the longer of the two. Right? Square root of 5 is more than 2, but it's less than 3. It's somewhere in here. There's your focus. And then, of course, you'd have one down, focus as well. Your vertex up there, your vertex down there. And again, I'm 99% sure the homework doesn't ask you, but this is the minor vertex here and the other minor vertex there. I can't recall, I've taught classes in the past where they wanted you to list those out. I don't think we care. But anyway, that is 9. Okay, let's look at number 12. Well, 12 is very similar, actually. Well, 12 is 4x squared plus 25y squared is equal to 100. So once again, we have to put it in the form that we're looking for. So I'll start this one off. Of course, we're going to divide everything by 100, just like we did in the last one. And in fact, it's so similar to the last one, I'm going to stop here because you should be able to do it if you just follow through the last one's process. So give it a try. If you still can do it, throw it back up on the discussion boards. I'll take a look at those, and I can throw a solution up there if we need to. All right, let's look at 11.3 then. The question that we had in 11.3 is about hyperbolas. So the last one on number 2. So I have a hyperbola that has asymptotes of y equals plus or minus x. We'll get to why that's important in a second here. And it goes through the point 5, 3. So it's a hyperbola. That means I have one of 2 formulas or equations. Okay, got that one. Or I've got this one. So I know that, you should know that if you have an x squared minus y squared, then your hyperbola will look like that, okay, be in that shape. There we go. And if you have y squared minus x squared, then you have up and down. So we'll get to which one we have in a minute here. But these asymptotes, y equals plus or minus b, tell us, or sorry, y equals plus or minus x. Our asymptotes are always y equals plus or minus, and depending on which one it is, it's either a over b x or y equals plus or minus b over ax, right? These, whichever one of these is just dependent on which equation you have. But since there's a 1 in front of here, that tells us that a is equal to b. In either case, it doesn't matter which case we have, we know that a is equal to b. So that's what we get from that. And then if I kind of picture out what I'm doing, what I know is that I've got asymptotes of y equals plus or minus x. So that's y equals x. That's y equals negative x. And I know I go through the point 5, 3. So 1, 2, 3, 4, 5, and 1, 2, 3. Well, that point right there tells me that I couldn't possibly have an up and down hyperbola. It has to be a left and right hyperbola. So I know I look something like this, right? Maybe not the best picture. It's making it worse. But I have something that looks like this, right? My hyperbola is a left-right hyperbola. So that means that I know the general form of my hyperbola is the x squared minus y squared form, right? And furthermore, I know that a is equal to b, so I could even further say that I have something that looks like this. X squared over a squared minus y squared over a squared equals 1. Right? So I'm going to erase all this. If you need to write it down, pause the video because it's going. I'm going to write this over here so I have it. I know that I've got x squared over a squared minus y squared over a squared again because a equals b in this case. Alright. So I know this. I've used what I have so far to figure this out, but I also again can use the fact that I went through the point 5, I think 5, 3. Yep, 5, 3. That means x is 5 when y is 3, so I can plug those values in, and the only thing that I would not know once I've plugged 5 and 3 in is a, and I can figure that out. So 5 squared over this a squared minus 3 squared over this a squared equals 1. Therefore, I can multiply everything by a squared, which will give me 5 squared, which is 25. Minus my 3 squared, which is 9. I've multiplied my a squared up here, so I get that equals a squared. And so I have 25 minus 9, which is 16, equals a squared. And if you want, you can say then it's plus or minus 4 is equal to a, but that doesn't matter. What I really care about is that a squared is 16. Okay? And that tells me my equation then. I have x squared over 16 minus y squared also over 16 is equal to 1. And that's my equation. So hopefully that helps. Again, keep going on the discussion boards. Answer questions if you see them. Ask questions if you have them. And I'll see you next time.